1.3 million Earth can fit in the Sun, and numerous suns can fit into the largest star in the universe. Are you feeling too small now? Yes, the size of the largest star in the universe is menacing enough. But what is the name of this star? Do you want to know more about it in detail? Well, hang tight till the end, as in this video, we are going to talk about the discovery of the largest star in the universe. Welcome to Space Discoveries. Subscribe to the channel for every single detail about the new discoveries in the vastness of the space. Also, do not forget to hit that bell icon for new updates. That being said, let's begin. As we were saying, our sun is enormous. It could hold more than 1 million Earths. On a stellar scale, however, it may be gobbled up by nearly half of all known stars, particularly those like UY Scuti. UY Scuti, the universe's largest known star, is a variable hypergiant with a radius almost 1,700 times that of the Sun. To put it in context, a sphere the size of UY Scuti could hold a volume of about 5 billion suns. The difficulty with stars is that they have hazy edges, noted University of Sussex astronomer Gillian Scudder for the conversation. Most stars lack a solid surface where the gas ceases and the vacuum begins, which would have served as a sharp dividing line and a simple marker of the star's death. Astronomers instead use the photosphere of a star to determine its size. The photosphere is the point at which the star becomes transparent to light, allowing light particles, or photons, to escape. This is the surface of the star as far as an astronomer is concerned, because this is the point at which photons can exit the star, Scudder noted. UY Scuti's photosphere would stretch just beyond Jupiter's orbit if it replaced the Sun in the solar system's center. The cloud of gas blasted from the star stretches 400 times the distance between the Earth and the Sun, far beyond Pluto's orbit. The huge radius of UY Scuti does not make it the most massive or heaviest star in the universe. R136A1, which has a mass of nearly 300 times that of the Sun but only 30 solar radii, is the recipient of this honor. UY Scuti, on the other hand, has a mass of just roughly 30 times that of the Sun but a much larger volume. Because UY Scuti does not stay the same size comparisons are much more difficult. Scudder pointed out that the brilliance of the star fluctuates in proportion to its radius, and the measurement we have currently had a 192 solar radii margin of error. Other stars may be able to beat UY Scuti in the race for its size due to the fluctuation or margin of error. There are as many as 30 stars with radii that approach or exceed UY Scuti's least estimated size, so the Colossus shouldn't be too comfortable on its throne. If UY Scuti's size were to be re-evaluated, which star would take its place? Here are a few contenders for the throne currently held by the 1,700 times the width of the Sun giant. WOH-G64, which was previously estimated to be 3,000 times the diameter of the Sun. According to a 2009 report published in the Astronomical Journal, newer estimations put it at roughly 1,504 suns wide. It's a red hypergiant star in the Milky Way's satellite galaxy, the Large Magellanic Cloud. WOH-G64, like UY Scuti, has a range of brightness. According to NASA, Westerland 126 is more than 1,500 times the width of the Sun. According to a 2012 article published in the journal Astronomy and Astrophysics, NML Cygni is 1,639 times the width of the Sun. In a 2012 research published in the journal Solar and Stellar Astrophysics, VY Canis Majoris was measured to be around 1,420 times the width of the Sun. This red hypergiant star was formerly thought to be 1,800 to 2,200 times the diameter of the Sun, but fresh observations have reduced its size. Some sources, however, continue to designate it as the biggest star. According to Astronomy magazine, German astronomers at the Bonn Observatory initially catalogued UY Scuti in 1860, designating it BD 125055 at the time. Astronomers discovered it grows brighter and dimmer over 740 days during a second study, leading to its categorization as a variable star. The star is around 9,500 light-years away from Earth, at the Milky Way center. UY Scuti is a hypergiant star that may be found in the constellation Scutum. Hypergiants are rare stars that glow intensely and are larger than supergiants and giants. Fast-moving stellar winds cause them to shed a lot of mass. UY Scuti has a maximum brightness of magnitude of 8.29 and minimum brightness of magnitude of 10.56, making it one of the largest known stars in terms of radius. It has a radius of approximately 1.188109 kilometers. It's about 2.9 kiloparsecs away from Earth. The star's brightness has altered slightly when it was discovered in the second survey, indicating that it was a new variable star. It was given the name UY Scuti, following the International Standard for Variable Star Designation, indicating that it was the 38th variable star in the constellation Scutum. UY Scuti is located northeast of the Eagle Nebula and a few degrees north of the A-type star Gamma Scuti. Although the star is extremely bright, it is only 9th magnitude as observed from Earth due to its distance and location within the Cygnus Rift's zone of avoidance. UY Scuti is a dust-encrusted bright red supergiant classed as a semi-regular variable with a pulsation period of around 740 days. This pulse would be an overtone of the fundamental pulsation period based on its radius, or it might be a fundamental mode corresponding to a lesser radius. The characteristics of 3 red supergiants near the galactic center area, UY Scuti, AH Scorpii, and KW Sagittarii, were measured using amber interferometry with the Very Large Telescope, VLT, at the Atacama Desert in Chile in the summer of 2012. They discovered that all 3 stars are more than 1,000 times bigger and 100,000 times brighter than the Sun. The sizes of the stars were calculated using the Rosseland radius, which is the distance at which the optical depth is 23. Distances were taken from previous publications. UY Scuti was discovered to be the largest and most brilliant of the 3 stars, measuring 1,708 solar radius based on an angular diameter of 5.48 milliarc-second and an assumed distance of 2.9 kiloparsecs, or about 9,500 light-years, calculated in 1970 based on the spectrum modeling of UY Scuti. The luminosity is then calculated to be 340,000 solar luminosity at an effective temperature of 3,365 Kelvin, resulting in an initial mass of 25 solar mass, with a non-rotating star having a mass of up to 40 solar mass. It would take nearly 7 hours for a hypothetical object traveling at the speed of light to travel through UY Scuti's Great Circle, but it would take 14.5 seconds to circle the Sun. Direct measurements of the parallax of UY Scuti published in Gaia Data Release 2 yield a parallax of 0.6433 milliarc-second, implying a closer distance of about 1.5 kiloparsecs or 4,900 light-year, and thus much lower luminosity and radius values of around 86,300 to 87,100 solar luminosity and 755 solar radius, respectively. However, due to a high amount of astrometric noise, the Gaia parallax may be incorrect, at least until more observations are made. This star has a parallax of 0.5166 milliarc-second, with a big value for astrometric noise rated at a significance of 122, where anything over 2 is possibly significant, according to Gaia Early Data Release 3. Because UY Scuti has no known companion star, its mass is unknown. However, theoretically, it is projected to be between 7 and 10 solar masses. At a rate of 5.8105 solar mass per year, mass is being lost, resulting in a vast and complex circumstellar environment of gas and dust. UY Scuti has begun to fuse helium and continues to fuse hydrogen in a shell surrounding the core, according to current stellar development models. UY Scuti is a metal-rich star due to its deep placement within the Milky Way disk. Its core will begin to create iron after fusing heavy elements, breaking the balance of gravity and radiation in its core and leading to a core collapse explosion. UY Scuti is anticipated to grow to a yellow hypergiant, brilliant blue variable, or Wolf-Rayet star, producing a strong stellar wind that would eject its outer layers and reveal the core before exploding as a Type 11b, 11n, or Type IBIC supernova. So, this is what we got for today's video. Tell us in the comment section how fascinated this video made you. In case you have any questions in mind, you may also ask them. Also, if you want to get more informative videos like this, subscribe to this channel and smash the notification bell to ensure you don't miss out on new updates. We will see you until the next one.